Hello, you're welcome back. So now we're going to treat the addition and subtraction of surds. Surds that are the same base or basic form can be added and subtracted. Now the basic form will be seen as like terms. So let's do some examples on addition of surds. So we have a quick example, which is plus root 32. So the question says simplify the surds. Okay, so what we're going to do, we're going to break down the surds to their most basic forms, and then we're going to add the like terms of those that are already basic. So we have the square root of 50. So what factors are we going to divide 50 into that have perfect squares? We know we have 25 and 50, 25 times 2, and 25 is a perfect square of 5. And then we have 18. 18, some factors in 18 that have perfect squares is 9. So we have 9 times 2 giving you 18, because we know that 9 is a perfect square of 3. Then we have 32. 32, a factor that rings in my head immediately I see 32 is 16. And we know that 16 is a perfect square of 4. So let's jump right ahead and simplify this problem. First, 5 times 2. Alright? That's for the first part. 25 times 2. And then we'll say minus, this is 9. 9 times 2, right? Then we have 16 times 2. Remember our first law of surds? We can break this down to individual square roots. So we have 25, root 25 times root 2, all right? Then we have root 9 times root 2. Then we have root 16 times root 2. All right? Are we clear? So the square root of 25 is simply 5 root 2. The square root of minus 9 is simply 3 root 2. The square root of 16 is simply 4 root 2. So these are like terms because they all have root 2 as their base. So we're going to add it up with a base of root 2, leaving us with 5 minus 3 plus 4. 5 minus 3 gives us 2 plus 4 gives us 6. So our answer is 6 root. So quickly, if you take a look at these surds that are written down here, which is 3 root 2 plus 2 root 3 minus 5, 4 root 5. Now, these three terms have different surd bases. All right? This is root 2, this is root 3, and this is root 5. Therefore, these terms cannot be simplified further because they do not have similar or the same basis. So this is the final. This cannot be simplified further. So this is another problem we have here. We are supposed to simplify these problems. All right? And this is root 80 plus root 20 minus root 45. So we're going to look for the terms, the factors inside these roots that are perfect squares. I can already pinpoint 16 as a perfect square in 80. I can also pinpoint 4 as a perfect square in root 20. And I can also pinpoint 9 as a perfect square in 45. So with that in mind, we're going to solve the problem. Just watch what I'm doing. We will have 16 times 5 here, plus 4 times 5 under 20, minus 9 times 5. So if we split it up according to our first law, we'll have this, right? Remember? Then we'll have this. Then we'll have root 5. Remember? Then we'll have root 9 times root 5. Alright? Square root of 16 we all know is 4. Root 5. Square root of 4 is 2, bringing down root 5. Minus the square root of 9, which is 3 root 5. So our final answer will have a base of root 5 because they're all root 5s there. So we have 4 plus 2 minus 3. 4 plus 2 is 6 minus 3, giving us 3 root 5. So this is the simplification of this sword problem. And so now the final problem we have here, we have the square root of 112 minus the square root of 28. So if we were to find the solution to this problem, we'll first of all find the factors which are in 112 that will be a perfect square. You can do that by finding the LCM, all right? So let's quickly find that LCM. You can find that LCM. We'll say 2 goes here, 56, 2 goes here, 28, 2 goes here, 14, 2 goes here, 7. So I can already see 7 goes here, 1. I can already see 4 times 4 times 7, right? Which is 16 times 7. All right? So with that, we're going to use these factors inside the square root. All right? So we'll have 16 times 7 for 112, right? Minus 28. We know we have 4 in 28, which is 4 times 7. So looking at it at a glance, we're already seeing the base of 7 here. So we'll split it up according to our first law, right? 4 times root 7, giving us the square root of 16 is 4 root 7. The square root of 4 is 2 root 7. 4 minus 2, first of all write the root 7. 4 minus 2 gives you 2. So our answer is 2 root 7. So this is our final problem. This is your assignment. So you simplify root 28 plus root 63 and write the answer in the comment section. And then I will respond to your answer whether you were correct or whether you were wrong. So I will see you in our next video. Bye. Remember, we are on this channel every day by 4 p.m. GMT+1. See you next time on EasyMathsTutor channel. Bye for now. EasyMathsTutor is proudly sponsored by Khalida Foods. If you want to be smart and be a maths lover, make sure you take your plantain flour, yam flour, turmeric powder, ginger powder, and rosemary powder. For more information, visit khalidaresources.com.